First up tonight, we have Alastair, Dant, and Jonathan Arnaldo.
We are going to tell you a bit about our company, Riffyn. When I say our company, we're not really the founders, so we might be a bit indiscreet in that sense. But Riffyn, very excitingly, is iterative process design and analytics software for R&D. So to try and translate that a bit, it helps scientists to design and then improve the design of their experimental processes. And we'll tell you a bit more about that. So just to introduce ourselves, I was, I think, employee number 2 or number 3, and I'm kind of heading up the UI stuff. And John has been working with me and hasn't quit yet. It's pretty good. And we're going to sort of share the presentation duties this evening. So John will just tell you a bit about what the company does.
Yeah. So how many of you guys know CAD software, computer-aided design? So my former previous life was as an architect, and one of the reasons I think Tim hired me is because of that. Because I guess the best analogy we can make to the software is through CAD. Typically, when you have large groups of engineers working, architects, engineers working, they'll break up the scope of work in terms of design into smaller teams, and then they'll come back and they'll kind of link things together, kind of as placeholders. And so that's kind of what our software does, except for scientists. So scientists can design processes kind of in tandem with each other. Maybe a group of scientists will design like I don't know what's a great example. Well, we'll show one in a minute, but for example, like boiling water and preparing it and things like that. And then we can link that back into another larger process. And we'll show you more complicated things such as like versioning and cloning and all that good stuff.
Yeah, so I think what was underlying what John was saying there, it's not dissimilar to doing kind of team-based development. In some senses, what we've tried to create is a kind of slightly more visually driven version of what GitHub does very well. So we're going to show you one of these kind of like startup promo videos. It's got some nice music, and hopefully it will help understand a bit more what we're talking about.
Oh, before we start that, I don't know. I don't watch Mr. Robot, but apparently this guy, like episode 4 or something.
He's our founder's cousin, but he's a professional actor, and he was in Mr. Robot, so there you go.
Yeah.
Computers have revolutionized how we make things. Architects used to draft these by hand. Today, they use design software. In fact, there's design software for almost everything, from making airplanes to cooking gas. But what about lab research? The laboratory is a little bit old-fashioned. We think it's time for something better. Meet Riffyn. Good morning. Riffyn automatically sends our data to the cloud and then maps it into my scientific procedures. That makes it easy to understand where it belongs and what it all means. Riffyn also tracks my measurements and warns me about potential issues. Glad we caught that one. Riffyn also allows me to collaborate with colleagues. We can share both our methods and our results without money for spreadsheets. In fact, every trial we've ever done is automatically compiled and analyzed together as one giant experiment. So we never miss an opportunity to discover. Problem solved. Oh, cupcakes. Riffyn didn't invent the cloud. We didn't invent statistical analytics. But we are putting them to work for the people who did invent them. Scientists and engineers.
So, we'll now have to descend from the lofty heights of the feel-good video to the reality of our software, which is hopefully going to showcase some exciting things that Meteor does. And we've generally, I think, it would be fair to say, enjoyed working with Meteor a lot. And I think in part that's because it's made the development process very easy, but It's also facilitated, some of the, I know, I need to do that, yeah. Okay, so we're going to step you through an example of the software at work. And imagine, if you would, that sometime during the course of today, John had this bright idea, which is that we needed to improve the quality of the coffee that we were making at our workplace. So what we have here is a very nice process flow that John's drawn up for the process that he uses to make coffee at home. So as you can see in this very elaborately specified flow, we basically measure some beans, grind them, boil some water, prepare our Chemex, because we're up with the sort of trendy stuff, and then we brew it and consume the coffee. And consuming of the coffee, do you want to show your little image there? You can annotate the steps. So the...
I forget where it is.
No, it's just... Yeah, there you go. Right. So, all right. It's not going to work for us tonight. Never mind. So yeah, the thing is that this initial version of the process, it turns out, is a little bit deficient when it comes to serving the entire office at once. So John throws it to me and he says, could you have a look at this and maybe suggest some changes? So what I did is I went in and I started modifying the process. And I've added this step here, which is actually a link to another process that I created elsewhere called hot water on demand. So what you saw there was the versioning on the right is a bit like the version history in GitHub, and it allows you to step through all the different versions that are being created. And with this link process here, we can actually sort of drill into it, and we can see that there's a pretty simple process that involves installing a hot water dispenser and then running it. But going back to our main process, this ability to link other processes is really a bit like using building blocks, Lego blocks or something like that. So I then made some further changes, and I introduced the idea of using a rack of pour-over cones rather than just a single Chemex. And that way we were suddenly able to do a lot of things in parallel. But the question arose, you scaled this thing up. Now, how do you ensure that everybody is getting a good cup of coffee? So we were sort of puzzling on that. And what I did was I started to actually set this process up in the same way that the link process was configured. So the input and output resources are actually exported to the group almost as if it was the sort of parameters and the return value of a function. And that way, this process can be plugged into a wider process for testing. And then what you can do is, when you specify individual resources, you can define the properties on those resources that you might want to test experimentally. So as I sort of worked on this a little bit more, I worked up to the point where the step here of measuring the coffee could actually introduce some variations. So what we decided was to create an experiment which was the dose versus productivity experiment. And the idea here was that we would try different levels of coffee, different amounts of coffee, on the entire development team and see how many lines of code they generated as a result. So that was our sort of outcome variable. Anyway, so you get the idea. And what we have sort of also got is this ability to create an experiment on your process. And then once you're in the experiment mode, you can go in and you can actually start to define these different variations and subsequently upload your data, analyze the data, and loop those findings back into your process design. So that's hopefully a sense of what we're working on. I'm going to tell you a bit about our general architecture, and then we'll just throw open a Q&A if you wanted to ask us any technical questions.
I thought you were going to do that.
Oh, all right, fine. I will. So yeah, this is the very broad sense of what our architecture is. We basically have a Meteor app running, which enables these kind of like nice concurrent editing features and the various other good things that I think you probably already associate with Meteor. We've introduced Elasticsearch, which is nice because we're able to actually do a real-time spotlight-style search of ontology. So in other words, when you're looking up resources, you can actually search against a very expansive database that we have in Elasticsearch. And that way, you don't have to sort of type in every last funny chemical. We've got an asynchronous task system that uses RabbitMQ to basically dispatch messages to something we're calling Red, which is effectively a task management system. So some of the longer-running data analysis tasks, we can basically sort of offload to that. And that's also the gateway into potentially larger-scale data analysis pipeline things that we're planning on in the coming sort of versions. And then that will basically talk directly back to Mongo. So what will happen is that as these tasks run, you can get real-time notifications and observe changes about their status through the app. So that's a sort of a... Oh, and then the agent up there is a charming robot that basically runs behind enemy lines, sending back data from firewalled environments where you might need sort of corporate SQL access or something like that. So yeah, that's a broad sense of what we're doing. But if you've got any specific questions, please fire away.
How did you build the graph component, the graph UI component with the lines going connecting the...
Yeah, so that was one of the earliest things that I sort of mocked up when I started. I didn't actually choose to use Meteor. It was a chap that helped build the original prototype, but I evaluated it and I thought that the development speed and various other features were really appealing. And so the first thing I wanted to know was, could I integrate it with D3? So I actually used to work at the Guardian and the New York Times building interactive graphics. So I had a fair amount of experience with building these kind of interactive things that would generally just consume a static data source. And in this case, I built a bridge so that basically in an auto-run block, there's a sort of an automatic combination of various data sources into actually an in-memory graph, which is then passed through to sort of D3 component. And it's built in such a way that D3 handles the deltas so that as changes are being made, potentially by someone on another machine, or between versions, as you saw there, the graph is sort of updated in real time.
Where are you hosted?
AWS. Yeah. We're using MUP for deployment at the moment. And yeah, we have a increasingly elaborate infrastructure.
Could you repeat the question, please?
Oh, sorry, yeah. So the question was, where are we hosted? And the answer was AWS. We are at a point now where we're also having to figure out how to put sort of like privately hosted instances into client sites. And that's an interesting challenge as well, but not impossible as far as we've seen so far. Right.
What did you pick for the UI? Is it a React, a Blaze?
That's a great question, yeah. So we're basically at a point where we've got a large code base now, and everything that we've got, we've built in in Blaze. But we've chosen a particular style of structuring the code base to sort of deal with the fact it was going to grow so much, which is quite component-oriented. And as we learned more about the opportunity to move to React, we've been kind of preparing to do that. So my question to Mark, I was kind of pleased to hear we'd be able to run both in parallel and then gradually sort of migrate across. All right, well, thanks very much. And I'm obliged to inform you that we are hiring, and if you're interested in what we're doing, we've got kind of contract roles and permanent things, so come and talk to us.
Thanks.